Good morning, students, colleagues, friends, and families. It is my pleasure to welcome you to the Spring 2021 Senior Research Symposium. Today is a culmination of many hours of hard work. You, the presenting students, have searched through databases and papers. You have defined a question. You have read paper after chemistry paper, and as a biologist, I congratulate you on that feat. You may have spent mornings, middays, and afternoons in the lab. You've planned and you've replanned and you've troubleshooted and you've adjusted your plans again. You may have synthesized some compounds, and you certainly synthesized findings, perhaps your own, perhaps from others, perhaps both. You've spent hours in front of your computer, analyzing, writing, and practicing your speech. Now you have put everything together, and you get to show off all you've done. We are so proud of you. Faculty mentors, congratulations. I know how much of your hard work is represented here. Friends and family, congratulations to you too. You've listened as your student poured out his trials and frustrations through this whole thing. Thank you for supporting them in all this time, and we're delighted that you're here to share in their success. And with that, I will turn this back over to Dr. Wen, who will explain how to enter the virtual breakout rooms.
Thank you so much. That was wonderful, Dr. Mark Hutchins. And we also want to congratulate the School of Science and Medicine for the student government last night. We won the best department. So congratulations to faculty, students, and staff for that great achievement. And Brendan won the Laker of the Year award. So that was also congratulations to you as well.
And Dr. Wen won the Advisor of the Year award.
So thank you very much.
Sure.
This morning, we have two rooms, the Beaker room and the Bunsen room. According to our undergraduate students, they thought that the reasoning for the Beaker and the Bunsen room was because it was science terminology. And how many of you actually know that that was a reference to the Muppet movie? So only most of us faculty members, so we're the only ones that thought that was okay. So there is a, if you're not sure what it is, you should Google Bunsen and Beaker, and you should pick that up. Okay, so the schedule, we're going to keep a schedule so that you are free to move back and forth between any of the rooms as you wish. You can see the schedule there. I've also put a picture of the schedule in the chat in case you need to find it again later. And it's also on the website. So at 9:10, we'll start the first presentation with Justin in the Beaker room and then Mariah in the Bunsen room. And we're going to keep to the schedule. And then if you are able to stay around afterwards, we'll do a quick presentation of awards for the outstanding graduates for this year. And we're also going to name them for last year because we didn't have that opportunity. So we'll be presenting them with awards. So if you have any questions, you can type them in the chat or you can unmute yourself. Otherwise, I will leave you to split into the rooms. If you need help getting into a room, I can assign you to one as your switchboard operator. Just let me know if you need any help. Otherwise, go ahead, I'm going to open the rooms and you can split. Faculty that are grading, you may go to whichever room you would like to go to. Thank you.
Good morning, everyone, and thank you for being here. Today, I will be presenting my research into the combinatorial treatment of HER2-positive breast cancer with trastuzumab. In the United States, cancer is the second leading cause of death, and in women in the United States, breast cancer is the second most common cancer. On the screen, you can see projections for the year of 2021, and from those statistics, it is evident that research into breast cancer is of importance due to the amount of women that will be diagnosed with and die from it every year. Breast cancer can be broken down into different subgroups, including invasive, non-invasive, and metastatic breast cancer. Those subgroups can further be divided into molecular subgroups, one being the human epidermal growth factor receptor 2 positive breast cancer, or HER2 positive breast cancer for short. HER2 positive breast cancer is distinguished by an overexpression of the HER2 protein, as you can see in the figure. And the HER2 protein is responsible for cell growth and proliferation. And when there's an overexpression of this protein, it can lead to malignant cells and ultimately tumor formation. Approximately 20 to 25% of all breast cancers are characterized as being HER2 positive. Now, to put this in perspective to the statistics shown earlier, more than 60,000 women in the year of 2021 will be diagnosed with HER2 positive breast cancer, making the HER2 protein an important therapeutic target. The extracellular region of the HER2 protein is accessible for targeted antibody therapy. One monoclonal antibody that binds with high affinity to the HER2 protein is trastuzumab, which can be seen on the screen. The exact mechanism of trastuzumab is unknown, but there are two main mechanisms it is believed to follow. The first mechanism is through antibody cellular cytotoxicity. In this mechanism, a natural killer cell, which can be seen in the center figure, recognizes and attaches itself to the antibody which is bound to the target cell. This then leads the cell into apoptosis. The second mechanism is through an inhibition of intercellular signaling. When trastuzumab binds to the HER2 protein, it interferes with HER2 dimerization. This leads to an inhibition of intercellular signaling and ultimately leads to cell cycle arrest. The objective of the study is to compare the effectiveness of trastuzumab in combination with other treatments. Specifically, we will be looking at chemotherapy, hormonal therapy, and one other monoclonal antibody that binds with high affinity to the HER2 protein called pertuzumab, which can be seen on the screen. This research will allow for a better understanding of how trastuzumab works and what treatments to offer patients suffering from HER2-positive breast cancer. For this literature research, SciFinder was used, and the keyword search dealt with trastuzumab's mechanism of action as well as trastuzumab in combination with the various treatments of interest. Because trastuzumab is used in various types of cancer, the articles were refined down to those specifically regarding breast cancer. Those articles were then organized by the number of citing references that they had. In this study, Calu-3 cells, which have consistently active HER2 protein, were injected into mice, and the size of the tumor was monitored over time. The mice were then randomly placed into groups and were either treated with a vehicle, with trastuzumab, with pertuzumab, or with a combination of the two antibodies. As you can see, with the mice that were treated with either pertuzumab or trastuzumab alone, there was little tumor growth. And for those mice that were treated with a combination of trastuzumab and pertuzumab, there was a decrease in tumor size. The results from the study can further be appreciated by looking at the size of the tumor for the various treatments in comparison to the vehicle. When trastuzumab or pertuzumab were used alone, the tumor size was reduced 62 to 65%. But when the two antibodies were used in combination, the tumor size was reduced to 97%. These results just scratch the surface of what trastuzumab can do in combination with other treatments. For patients treated with chemotherapy A, they either received anthracycline and cyclophosphamide or paclitaxel. Some of those patients were then selected to receive additional treatment with trastuzumab. For patients treated with chemotherapy B, they were split into two groups. The first group was treated with a combination of oral lapidem and oral capecitabine. The second group was treated with an antibody-drug conjugate called T-DM1. An antibody-drug conjugate is created by chemically linking a cytotoxic agent to an antibody. Our cytotoxic agent in this case was DM1, and our antibody was trastuzumab. For patients receiving hormonal therapy A, oral anastrozole was taken, and some of those patients were randomly selected to receive an additional treatment of trastuzumab. As you can see, in all studies, there was an increase in progression-free survival with the addition of trastuzumab to the treatment. In order to compare the effectiveness of the treatments, the increase in progression-free survival with the addition of trastuzumab was calculated. Overall, with the addition of trastuzumab, the progression-free survival increased from 50% to 100%, with hormonal therapy A exhibiting a 100% increase in progression-free survival with the addition of trastuzumab. In more human trials, the addition of pertuzumab to those combinations were investigated. For patients receiving chemotherapy C, docetaxel and trastuzumab were used. Some of those patients were then randomly selected to receive additional treatment with pertuzumab. For patients receiving hormonal therapy B, oral anastrozole and letrozole were used in combination with trastuzumab. From those patients, some were randomly selected to receive additional treatment with pertuzumab. In both studies, the addition of pertuzumab showed to increase the progression-free survival. Once again, in order to compare effectiveness, the increase in progression-free survival was calculated for these treatments. Interestingly, in this study, hormonal therapy B showed to have less increase in progression-free survival in comparison to chemotherapy C. In the first analysis, we saw that the increase in progression-free survival was highest with the combination of trastuzumab and pertuzumab, but we did not see this in the second analysis. This could be explained through signaling pathways. As stated earlier, both pertuzumab and trastuzumab bind to the HER2 protein, but they bind on different locations. By binding on different locations, this could lead to an increase in antibody cellular cytotoxicity or an increase in signal inhibition due to the interference with dimerization. This could explain the results we saw when pertuzumab was used in combination with trastuzumab. In addition, there is a suggested crosstalk between the pathway that trastuzumab utilizes, called the HER2 pathway, and the pathway that the hormonal therapy drugs utilize, called the estrogen receptor pathway. This crossover could lead to a greater signal inhibition when hormonal therapy and trastuzumab are used in combination. Now you may ask why we didn't see as big of an increase in progression-free survival when pertuzumab was added to the combination of hormonal therapy and trastuzumab. This could be because hormonal therapy and trastuzumab together were already exhibiting an increase in signal inhibition. With the addition of pertuzumab, it wasn't allowed to exhibit its full ability of signal inhibition. Now, the mechanism of trastuzumab and chemotherapy, on the other hand, aren't believed to have any crossover. So when pertuzumab was added to that combination, it was allowed to exhibit its full range of signal inhibition, leading to a greater increase in progression-free survival. Although chemotherapy in combination with trastuzumab exhibited a higher increase in progression-free survival compared to the antibody-drug conjugate, the antibody-drug conjugate allows for a more targeted approach to chemotherapy and could therefore reduce the toxicity seen with regular cytotoxic agents. This could be an important factor for patients to look at when looking at the various treatments. Overall, for this research, we saw that when trastuzumab was used in combinatorial treatments, there was a reduction in tumor size. Additionally, when trastuzumab was used in combination with chemotherapy in an antibody-drug conjugate, in combination with hormonal therapy, and in combination with pertuzumab, there was an increase in progression-free survival. If there were to be further research into the effectiveness of trastuzumab used in combinatorial treatment, it would be beneficial to have studies from the same time frame, studies with baselines for all treatments used, and studies with the same form of chemotherapy and hormonal therapy. This would allow for a more comprehensive comparison of the different treatments used in combination. I would like to thank Dr. Nguyen for all of her guidance throughout this project, and I'd like to thank you for your time.
Okay, does anyone have any questions? Now she looks nervous. You have to ask her some questions. Where's Dr. Retsky when you need him?
I just don't have any questions. How about that?
Can you tell us about where you think the future of this research is actually going and the level of effort maybe that's being put into it? Did you see that in the work you were looking at?
Yeah, so interestingly, with what I find really interesting is the antibody drug conjugates with the specific antibodies, because that leads to a decrease in the toxic effects seen with regular chemotherapy, which is obviously a big turnoff for people when they are comparing quality/quantity of life they have. And interestingly, in our advanced cell molecular biology class, we actually are talking about cancer, and trastuzumab got brought up, but there's also CAR T therapy. So that's another interest where I think this research is going to end up going. So I think the more targeted approaches and a way to use our body's natural way of interacting with these molecules in order to deliver these other like cytotoxic agents specifically to where they need to be to reduce the effects on healthy cells.
That's a good question. And you're brought up another question. How do we do that? So how do we target these specific, chemicals to only, cells that we are interested in, in damaging as opposed to healthy cells?
Yeah. So more specifically in terms of that antibody drug conjugate, because it is linked to trastuzumab, and trastuzumab binds to the HER2 protein, if a cell is overexpressing the HER2 protein, that cell is going to have more trastuzumab binding to it, and therefore it's going to be delivering more of that cytotoxic agent, specifically to that cell, which will deliver that cytotoxic agent, as well as having the effects of trastuzumab with that. So there is still the potential that those cytotoxic agents are being delivered to healthy cells, but it'll be on a lower scale because the normal cells will be expressing less of the HER2 protein in comparison to those HER2 positive cells.
Thank you for that. Anyone else have any questions?
Does anybody have questions for Mariah real quick while I get the next video queued up? I apologize for the technical difficulties. So we'll move on to Brendan. He is going to be working this at Cambium Analytica after doing an internship there last summer. He was one of the fortunate students that got an internship. And He's also going to be doing a biostatistics master's through the University of Florida. And in what free time he finds, he likes to do novel writing. All right, here is Brendan's video.
Hey everyone, my name is Brendan Lukomsky, and today I will be discussing my research into nickel contamination in vaporizer cartridges used for cannabis concentrates. Now, just a little bit of background before we begin. A vaporizer pen typically heats and aerosolizes a liquid concentrate, or in this case, a cannabis concentrate, that's stored in a replaceable cartridge that can be loaded and unloaded within the pen. Now, vaporizer pens have seen increasing use in recent years for a variety of reasons. One, they're discreet. Two, they're easy to use, and they're generally seen as a healthier alternative to cigarettes. However, this increasing popularity has also brought with it increasing scrutiny. Vaporizer pens have had countless claims leveled against them for contamination issues, the most recent of which appearing to be metal contamination. Now, it's quite clear that if these claims are true, this is a serious public health concern that does have to be addressed and researched, which ultimately was the motivation behind this study. Now, the state of Michigan currently mandates testing into 7 heavy metals, seen here in this table, alongside their corresponding action limits, or the concentration they have to fall below in the product to meet compliance testing. But for the purposes of this study, we chose to focus on one in particular, nickel. Now, nickel is the newest element of this table, only mandated for testing this past summer, the summer of 2020, and it stands out among the rest of them in that manufacturers have not yet had to account for it being there, and so frankly, it's everywhere. Nickel and chromium are 2 primary components of stainless steel, which is used extensively in the manufacturing process, from everything from the machinery used to manufacture the cartridges, right down to the construction of the cartridges themselves. The heating coil, which is a primary component of the cartridge, is composed of stainless steel. And nickel from this stainless steel can be introduced to the product through a process known as metal leaching. Now, metal leaching occurs when a metallic component comes into contact with a product in which certain amounts of that metal are deposited into the product itself over time. Now, taking into account that there are countless ways that nickel can be introduced into these cartridges, for the purposes of this study, we chose to focus on primarily metal leaching, as this is a primary concern considering the construction of the cartridges and one deserving of further research. Luckily, I was able to carry out this research at a safety compliance laboratory in Traverse City, Cambium Analytica, that had no shortage of clients that were willing to lend us a hand. I was able to obtain 90 cartridges from 4 different manufacturers for use in this 10-day study. Now, it's important to note that these were stock cartridges, meaning cartridges straight off the manufacturer floor that hadn't undergone any of the steps in the downstream production process where the cartridges are stocked with cannabis concentrate. Thus, any nickel contamination that we potentially found would be a direct result of either the manufacturing process or the construction of the cartridges themselves, with nickel being introduced via metal leaching. Now, I stocked these cartridges with vegetable glycerin, which had a negligible nickel content, and then placed 30 from each manufacturer into 3 different temperature environments, a 4 degree, a 25 degree, and a 37 degree environment. On each of those 10 days, I then removed 3 cartridges, digested their contents through microwave digestion, and then analyzed them for nickel content through ICP-MS. And the results were actually quite striking and did go to show that there was a certain amount of nickel content caused by metal leaching. This plot here shows individual cartridge nickel concentration for each of the 10 days for all 4 of the manufacturers we tested. And it really starts to show a lot of the relationships that we were able to extrapolate from this data. First off, this plot definitely shows the manufacturer variation, with manufacturers B and D experiencing many more cartridges above that black 500 parts per billion action limit line than manufacturers A and C. We also begin to see a temperature dependence, with many more of the red and green dots, being the 37 and 25 degrees Celsius environment, being above that action limit than the blue 4 degrees Celsius dots, indicating that there could be a temperature dependence. More on this relationship later. However, what this plot really starts to illustrate is the tremendous amount of variation within individual days. We actually experienced tremendous amount of variation within triplicate cartridges themselves, cartridges that were sampled on the exact same day and subject to the exact same conditions. In fact, the average relative standard deviation among these cartridges was over 50%, a variation that can really be illustrated in this plot, in which the same data is expressed as box plots. And we can really see the variation here, with some box plots on certain days extending all the way from 0 parts per billion all the way to above the action limit. A tremendous amount of variation that could be brought about by individual cartridge variation or even sampling conditions. However, this plot also begins to show the time dependence, or lack thereof. Manufacturers A, C, and D experiencing next to no time dependence with their concentrations, with manufacturing B being basically the only one you could really make a case for, but even that one's a very weak dependence. Overall, this does show that time plays a very insignificant role in determining the amount of metal that's leached into these cartridges. This plot summarizes the concentration data from the past two slides as percentages falling within certain concentration ranges, with the blue bar representing concentrations between 250 and 500 parts per billion, and the gray bar representing concentrations above that action limit of 500 parts per billion. And it really starts to illustrate the tremendous amount of manufacturer variation we were seeing, with manufacturer B clearly faring the worst out of the four we tested, followed by manufacturer D, and then A and C falling in at about the same level. So this definitely starts to show that what manufacturer is used in the construction of these cartridges does play a role, and that certainly their process and the way in which they construct the cartridges does play a significant factor in determining how much nickel is leached into the product. This plot summarizes the data in a similar fashion, but instead of comparing manufacturers, we're comparing temperatures. And it really starts to illustrate that the higher temperature environments generally saw an increase in metal leaching compared to the lower temperature environments, with the 37 degrees Celsius environment showing higher concentrations in that gray 500 parts per billion range and in the 250 to 500 parts per billion range than the 25 degrees Celsius and the 4 degrees Celsius environment respectively. Therefore, it does show that there is some dependence on temperature as well in determining how much nickel is leached into these products. So what does this tell us? Well, for one, it tells us that environmental factors don't really play a role in determining how much nickel is deposited into these products due to metal leaching, and that it's really down to individual cartridge variation caused by differences all the way back in the manufacturing process. Therefore, due to the ability of these stock cartridges to deposit toxic levels of nickel into the product itself, it definitely shows there has to be a changes in both the regulations and the practices manufacturers are undertaking in the construction of these cartridges. As it currently stands, cartridges obtained from the manufacturer by the producer can very easily be pushed over the action limit by aspects of the production process. Currently, the machinery used to stock these cartridges with cannabis concentrate is constructed of stainless steel. That and the capping process of these cartridges, which is either done through a hydraulic press or a screw-on cap, could very easily flake off parts of the stainless steel into the product and lead to compliance failures. These failures could potentially cost the producer hundreds of thousands of dollars, but this is not just a producer issue. This is also an end user, a consumer issue, the people that are actually using these cartridges. Due to the high variability in how nickel is leached into these products over time, cartridges which have already passed compliance testing and therefore been labeled as safe can very easily later be found with concentrations of nickel which exceed the action limit due to metal leaching. Therefore, this could be a huge public health concern due to the fact that cartridges which have been labeled as safe by the state of Michigan are therefore getting into the hands of consumers with toxic levels of nickel. Now, the manufacturers that took part in this study have already been notified of its findings and are taking the necessary steps to resolve the issue, both for their sake and for the sake of public health. However, if this issue is really going to change and the public health concern is going to be resolved, this has to be more than just for manufacturers. There has to be wide sweeping change within the industry in changing both the regulations governing these cartridges and with the manufacturing processes that produce them. Now I would like to acknowledge a couple fine people, including the tremendous workers at Cambium Analytica, including Genevieve Chevalier, who taught me basically everything I need to know about ICP-MS, Leslie Nagy for her help in writing up this thesis, and Alex Adams for his help in funding it. At Lake Superior State, I'd also like to thank Dr. Wynn for helping me to compile it in such a way that I can communicate it to you guys. Thank you very much for listening, and have a great day. So the current Michigan action limit is actually brought over from the e-cigarette industry and the action limit seen there. And this is kind of the consensus, I believe, of like the minimum level of which you start to see allergic reactions. That's really the big reaction you start to see with nickel. About 10% of the population develops some sort of allergic reaction to nickel. And so this is the level that they start to see it at. Of course, the more nickel you get, the worse outcomes you start to get. There are a couple studies that cite nickel as a carcinogen, especially in nickel refinery workers. There's some studies done on that. But 500 is generally accepted to be kind of like the minimum level of which it's safe. So that's kind of where the state of Michigan came from in coming up with that limit.
Any other questions for Brendan? I see one from Lucas. Go ahead.
So did you find any papers that discussed the correlation between how the heavy metal contents of those actual cartridges would translate into the heavy metal concentrations in the inhaled vapor?
I did not find any papers on that, and it's funny you should say that. I'm going back to Cambium in May, and we actually want to go in that direction for further research to find out what type of nickel compounds are in the vapor, because we're expecting the nickel is going to form other sorts of compounds, sort of organometallics, which might be a lot more dangerous than just nickel would be. So it's definitely an interesting direction of research that I'm excited to start pursuing.
Thank you.
Does anybody else have questions for Brendan? Okay, so our next speaker is Caitlin Vogelaar. She says for her future, she'll be doing more schooling. And I heard through the grapevine that it may be here, but I'm not sure. She can, I guess, tell us in a little bit here. Hi. And her fun fact is that she loves action movies. Do you have a favorite action movie, Caitlin?
I'm actually a big fan of the Fast and Furious. I don't know why, but.
All right, so I'm gonna play Caitlin's video for you now.
Hi, my name is Caitlin Vogelaar, and today I'll be comparing oral fluid, breathalyzer, and blood test. For many years, blood testing was the golden standard for determining blood alcohol concentration. This led to scientists wanting to develop roadside instruments to help with law enforcement with detecting the blood alcohol concentration in a DUI offender's body. The first instrument developed was the drunkometer by Dr. Aaron Harker in 1935. With this invention, a blood alcohol concentration of 0.15% was able to be set in 1938. This was because the information from the drunkometer could be used as scientific evidence in the court of law to help prosecute drunk drivers. Later, in 1954, Dr. Robert Borkenstein invented the first official breathalyzer. By the creation of these two devices, they helped contribute to the idea of researching and developing new and more methodologies to detect blood alcohol concentration, but by utilizing other biological matrices. This overall led to the first oral fluid testing for the DUI-related offenses in 1984. The purpose of my research is to compare three biological matrices: oral fluids, breath, and blood. Oral fluids and breath can both be collected on a roadside basis at the scene. Oral fluids would be collected by swabbing the inside of your inner cheeks and under your tongue, whereas a breath sample would be collected and analyzed by a breathalyzer. A blood sample would be collected in a healthcare facility by a trained professional using sterile equipment. The objective of this research was to determine which would be the most appropriate matrix for testing in terms of cost-effective, easiest to use, and time efficiency. My literature search was done by using Google Scholar as my search engine. I would search terms like blood testing for blood alcohol concentration, oral fluid testing for drugs or alcohol, breathalyzer tests. Based off the results, I would refine my results by looking for peer-reviewed journals, and based off of the results of that, I would review the abstracts and determine whether the articles found would be applicable for my research. The first category compared was the expense of the three tests. For oral fluids and breathalyzers, neither of them require a medical professional or facility, so this would cut out the cost of an hourly wage or a salary for a healthcare professional. For oral fluids, there's no shipping or disposal expenses since it's not considered a biohazard, whereas for blood, there is a required healthcare professional and facility for sanitation purposes. Blood is considered a biohazard, so there is shipping and disposal costs. There is an extensive pre-treatment and the use of expensive instrumentation. Specific instrumentation typically used for blood testing analysis is gas chromatography mass spectrometers and liquid chromatography mass spectrometers. Each of them could cost up to tens of thousands of dollars. But for a breathalyzer, you just have to pay for the device itself, which is typically inexpensive, but it also brings in the fact that you don't have to pay a per sample cost. The second category compared is the contamination aspects of the three tests. For oral fluids, a stimulant could be used to help produce a larger amount of specimen sample. An example of a stimulant would be gum or sour candy. But if you do use a stimulant, it can dilute your sample, causing a pH change. And based upon the consumption of the drug or alcohol, whether you smoke it, inhale, or take it orally, it could contaminate your oral cavity. For blood, the sample is collected by sterile equipment, and it's done by a healthcare professional. It's collected directly from the vein, and blood has a consistent pH of 7.4, so there will never be uncertainty of what the blood alcohol concentration is. And a breathalyzer collects the specimen sample directly from the donor to the device, and it is analyzed right there in the device as well. The third comparison was done with the sample collection process of the three tests. For oral fluids and breathalyzers, they're both quick and non-invasive tests because you don't have to, for instance, puncture through a donor's skin to collect the sample like a blood test. So for oral fluids, if there is a decreased salivary flow or dehydration present, it could reduce your ability to collect a proper sample amount. For blood, there is less potential for contamination because you're collecting directly from the vein, but there is a warrant required. And for the breathalyzer, it collects a controlled volume each time that you use the device. The fourth and fifth categories that were compared was the time efficiency and ability to collect a proper sample size. For oral fluids, if there was a decreased salivary flow or dehydration, there's a potential for collecting a smaller volume if there was no stimulant used. But as discussed before, the purpose of a stimulant is to help produce a larger sample. So if you were to use gum or sour candy, it could dilute your sample and change the pH because it contaminated it. For blood, it is collected directly from the vein, so the same volume is collected each time. And for a breathalyzer, the device collects only a specific amount that it needs for proper analysis. For the time efficiency of oral fluid and breathalyzer tests, they both can be tested on site and have results within 5 minutes. For blood, there's the added time restraint of waiting for the approval of a warrant, and also it could take several days just to receive results. This could be due to the backlog of a lab or even just waiting on the instrumentation itself to analyze the blood sample. This research was done in order to see which of the three tests would be most appropriate for the use by law enforcement agencies. This was done by comparing 5 different categories: expense, the contamination aspects, how you collect a proper sample, the ability to collect a proper sample size, and time efficiency of each test. It was concluded that only the law enforcement agency themselves could determine which of the 3 tests would be most applicable for their use. This is because they're the only ones that truly know what they need out of the test. For example, if they knew that they needed a test that would give them rapid results and they could use right at the scene, they're not going to choose to do a blood test where you have to transport the offender to get the specimen collected by a healthcare professional and wait for the test to be analyzed to get results. You're going to choose a breathalyzer or a presumptive oral fluid test where you can get the test administered and get the results within 5 minutes. And I would like to acknowledge Dr. Nguyen for all of her help assisting me throughout this research and throughout the year. Thank you very much.
Maybe you're just really excited about puzzles and trivia. Okay.
I put a question in the chat.
I'm sorry.
Yep, I'm reading it. One moment. Not exactly, but through the literature research that I did, I know that the oral fluid tests currently, they're trying to like develop them more. So they're not currently used very much. But I know there's a lot of research going into actually making like breathalyzer devices, but for a collection of oral fluids. And that's because they want to be able to analyze them right at the scene, just like a breathalyzer. But currently, they really only have the like presumptive test for oral fluids that later get analyzed by instrumentation. And then I know blood tests are they're still like the golden standard for determining blood alcohol concentration just through the years and not really having issues. And then I know breathalyzers are also pretty commonly used, but I'm not 100% sure in terms of like a personal preference of law enforcement.
So Ashley Mullings is our next speaker. And she's been working with me, and next year she will be taking an opportunity year to figure out some things. And her fun fact is that she is the youngest of six siblings. All right, so here is Ashley's.
Thank you for the introduction. Today, I will be presenting on peptoids inhibiting bacterial growth. So antibiotic resistance has been on an increase over the past decade. And though antibiotic resistance has a lot of causes, some major contributors are the overprescription of antibiotics, mutations in bacteria, patients not completing their medication, and overuse of antibiotics in livestock and fish farming, poor infection control in healthcare settings, and poor hygiene and sanitations. The image shown is the projection of the global working age population that is projected to be lost to the superbug in millions if this issue is not controlled by 2050. So it is seen that 100% resistance is expected by 2050, and 444.1 million persons will die as a result of antibiotic resistance. And what this essentially means is that by 2050, there will be no drugs that will be able to stop these microbes from multiplying and essentially causing death in individuals. More than 2.8 million antibiotic resistant infections occur in the US each year, and more than 35,000 people die. It is actually projected that the death toll will be around 10 million if this issue is not controlled by 2050. The image here actually shows the antimicrobial resistance mortality rate per 100,000 persons in the world. And it is seen that Italy will lead the world by 2050 in the amount of deaths occurring, with 18.17 persons per 100,000 if this issue is not controlled. The US ranks second with 8.98 per 100,000 persons, again, if we do not find a solution to antimicrobial resistance. So peptoids, a family of peptidomimetics, have their side chains bonded to the nitrogen atom in comparison to peptides who have their side chains bonded to the alpha carbon. So what makes these peptoids so much better than peptides is the fact that this N-substituted amide actually makes it resistant to proteolytic degradation, which is very advantageous because that allows it to survive in the cell much longer and thus be able to inhibit lots of bacterial growth and be able to use for a longer amount of time. So peptoids are typically synthesized on a resin using solid phase synthesis. The synthesis typically proceeds via a repetition of amidation steps. First, an amide bond is formed with bromoacetic acid and Dic in dimethylformamide. Then any primary amine can be used to substitute the bromine. Then the resin is cleaved and the steps can be repeated to achieve any desired length that you want. So in order to make these peptoids cyclic, they're typically made from their linear precursors and are synthesized on 2-chlorotriethyl chloride, on that's a resin, to generate a free N-terminal amino and C-terminal carboxyl acid, and then that is cleaved with hexafluoroisopropanol and dichloromethane in order to get your cyclic product. So the objectives of this project was to analyze the existing literature to figure out what structural characteristics of peptoids would be most efficient at inhibiting bacterial growth. In order to achieve this objective, JSTOR and ProQuest was searched using key terms in order to narrow down articles that were peer-reviewed and not more than 30 years old, as this was when peptide research was on a rise, and that was when the most information was out about peptides. So in order to establish this review, linear versus cyclic peptides were compared. And in order to do this in this study, the researchers used a variety of linear and cyclic peptides, and peptides were used as positive control, as seen with the linear peptide LGS and the cyclic peptide CGS that were used as positive control in order to provide comparisons into how well these linear versus cyclic peptides actually performed. So in order to have this comparison, the minimum inhibitory concentration, MIC, was used to determine how well these peptides are performing. What the MIC value is, it is estimating the lowest amount of drug that can be used to inhibit the bacterial growth, and thus is synonymous with how well the peptide is performing, which is its antimicrobial activity. So it is found that cyclic peptides had a lower MIC value in comparison to their linear peptides. And can be seen here, the linear peptides are in blue and the cyclic peptides are in orange. So it is seen across all 5 peptides here that the cyclic peptides outperform the linear peptides and produced a lower MIC value in comparison to the linear peptides. How they did this is that by making the peptides cyclic, it enforced a conformational rigidity that increases specificity. And what that means is by making these peptides cyclic and rigid, it was able to increase the cell penetration and thus targeting the specific area of the cell that was needed, the cell membrane, and not moving around the cell to other areas that would reduce its effectiveness. Another property that was investigated was whether or not lengthening the peptide would make a difference in increasing the antibacterial activity. And it can be seen that with the exception of the hexamer C6, increasing the length of the peptide does in fact increase the antibacterial activity. The prefix here, mer, refers to the number of residues used in the peptide. So a 6-mer has 6 residues, an 8-mer has 8 residues, and a 10-mer has 10 residues. So it can be seen that the 10-mer performed the best in comparison to all the peptides, which correlates with the idea that increasing the length of the peptide does indeed increase the antibacterial activity and result in a lower MIC value. Another property investigated was whether or not fluorinating the peptide would have an impact on the antibacterial activity. So in this study, fluorinated peptides versus non-fluorinated peptides were again compared using the MIC values and determined whether or not adding fluorination would impact the antibacterial activity. Compound 1 was actually not fluorinated to use as a control in the experiment, and all the peptides had different degrees of fluorination, which will be seen in the table. So it is found that fluorination does in fact increase the antibacterial activity, and how it does that is by increasing the hydrophobicity, which is seen as synonymous with increasing the antibacterial activity of the peptide. Compound 2 was found to be the most effective at inhibiting the bacterial growth across all 4 strains of bacteria. SA being Staphylococcus aureus, MRSP being methicillin-resistant isolate of Staphylococcus pseudointermedius, PA being Pseudomonas aeruginosa, and EC being Escherichia coli. The comparison that can be seen here is that compound 6 was also very effective and very similar to compound 2 in inhibiting bacterial growth across all 4 bacterial strains, and they also had the same number of residues. But what made compound 2 the most efficient at inhibiting the bacterial growth is the fact that, again, compound 2 was a longer peptoid in comparison to compound 6 that was a shorter peptoid. So it again enforces the idea that lengthening the peptoid does in fact play a role in increasing the antibacterial activity. All in all, cyclic peptoids are more efficient at inhibiting bacterial growth in comparison to their linear counterparts. Fluorination will in fact increase the antibacterial activity, but only to a certain point. Fluorination has a saturation point where adding more fluorine will only render the peptide ineffective because it will no longer be able to carry out its task. Increasing the length of the peptide as well does in fact increase the antibacterial activity. And in order to constitute the most optimal design of a peptide, a combination of fluorination and elongated hydrophobic side chains would be best. Thank you.
Thank you, Ashley. Any questions for Ashley? Questions for Ashley?
Hey, Ashley, I've got a question.
Go ahead, Dr. Mo.
Oh, so you mentioned that cyclic peptoids are more efficient at inhibiting the bacterial growth than linear peptides. And a lot of times you find that just cyclic molecules in general have enhanced bioactivity relative to linear ones. Can you speculate as to why that might be?
Okay, so I had explained that because these peptides are made cyclic, they enforce a conformational rigidity in comparison to linear peptides that make them a bit more flexible. This flexibility reduces how specific these peptides are able to inhibit bacterial growth because they don't actually target the portion of the cell that is needed to disrupt the bacteria's activity with the cell membrane. So making them cyclic enforces them to be rigid and target the specific area of the cell that's needed to stop these bacteria from working.
So I guess the second part of that then would be is that on occasion, though, there are molecules that aren't cyclic that are much more potent when they're in the linear form. Where would those maybe be, and which targets do you think those would be very active? Say compounds that are long and linear but not cyclic.
Could you repeat that question?
Oh, so so there are occasions where linear compounds are more active than cyclic ones.
Mm-hmm.
So what type of targets do you think that those type of compounds would act on?
So I think they would act on the different amino acids that's present in those bacteria's cell membrane. So instead of targeting the cell membrane directly, it might target the extracellular portions of the cell and target their other cell functions in order to reduce their activity.
Okay.
We're going to move on to our next speaker, which is Courtney Simpson. She's one of our integrated sciences majors. She is currently looking for a teaching job in Minnesota. And her fun fact is that she has visited 10 different countries. And she will be giving a talk on inquiry-based learning.
This research was completed to determine the effectiveness of inquiry-based learning and virtual laboratory experiments in both traditional and virtual classroom settings. Inquiry-based learning varies from traditional teaching methods in which, traditionally, the teacher is the main source of information in the classroom and the students only learn from the teacher. In inquiry-based teaching methods, students are allowed to guide their own learning. This is done in multiple formats where students are asked open-ended questions, they're asked to form their own hypotheses and then design and complete their own experiments, or they are viewing demonstrations done by the teacher. Inquiry-based learning is recommended by the Next Generation Science Standards, or NGSS, which is a national set of standards in science teaching that are derived from inquiry-based learning methods and encourage student experimentation to collect their own evidence. Virtual laboratory experiments or experiences are the use of virtual software to complete typical laboratory experiments in a virtual environment. There are multiple websites and different softwares available for these experiences and allowing for learning. These experiences have shown an increase in student engagement, improvements in overall comprehension, and simplifying student understanding processes. Additionally, virtual experiences give students more opportunities to explore multiple different phenomena, especially ones that are unavailable in traditional physical classrooms. Traditional classrooms are classrooms in which students and teachers are both in person in a classroom learning together. Virtual classrooms are when there's the use of a virtual site in order to teach a course. This can be done in two ways. Either synchronously, where the teacher and students meet at a certain time to discuss the class and complete assignments, or asynchronously, where the teacher posts lecture materials, such as videos or information, on the virtual site and allows students to view it when they are able to and complete the assignments later. Research that has been done in inquiry learning classrooms showed increased engagement, participation, and test scores with the majority of the students. Additionally, research done with virtual laboratory experiments and the benefits of those in the classroom showed that students are able to view the microscopic world with virtual laboratory experiments, which then aids them in understanding their everyday life and future science courses. The objective of this research was to review the current literature concerning the use of inquiry-based learning methods, virtual laboratory experiments, or both in the classroom, specifically in virtual or traditional classrooms. Also, there was time spent observing and teaching in a blended high school chemistry classroom. My methods for choosing literature were based on this criteria here. All materials had data on virtual laboratory experiments or inquiry-based learning, or both. Publication dates were between 2014 through 2021. All materials were published in a peer-reviewed journal, and studies included students of all ages and location. Additionally, all materials included multiple different assessment methods. These included pre- and post-test scores, standardized testing scores, general classroom assessment scores, and formative assessment results. Observations were done between January 2021 and February 2021 in a classroom where students were working with virtual experiments, traditional teaching methods, student-led inquiry, and on individually paced curriculum. In a case study reviewed at the National Secondary School in Malaysia, 147 fourth grade students were separated into two experimental groups. The control group, which used a physical laboratory, and the experimental group, which used a virtual laboratory. Each group was put through a pre- and post-test, which was based on the Science Process Skill Mastery Test, or SPST. The results from the SPST included a pre-test for the control group, experimental group, and total of the students, and then a post-test for the control group, experimental group, and total of the students. Each group was broken down by male, female, and total students, which included the mean, standard deviation, and total number of students within that category. The pre-tests were relatively similar for both groups. However, the post-tests, after results from a student t-test, showed a statistically significant difference between the control group with the physical laboratories and the experimental group with the virtual laboratories, in which the experimental group had much higher post-test scores than the control group. Overall, students showed benefits from the use of physical and virtual models in the classroom, which allowed them to see the submicroscopic levels of science that are invisible to the naked eye. These submicroscopic levels are incredibly difficult for students to comprehend without a visual representation. Therefore, the use of virtual environments can benefit students' conceptual learning as they are able to visualize things that are impossible to see in everyday life. One example of this is submicroscopic or subatomic particles, in which typically those are unable to be seen in a chemistry or science laboratory. However, through the use of virtual environments, they can be simulated and students can learn about them. Overall conclusions from literature showed improvements in content understanding and comprehension in a majority of the studies that used either inquiry-based learning, virtual laboratory experiments, or both. There were a number of testing methods used. However, pre and post test scoring was the most common. Additionally, inquiry-based learning on its own did show an increase in both understanding and material comprehension for students. In the science classroom, the chemistry classroom, which was observed, there was an informal study where students were asked to raise their hands if they agreed with the statement and keep their hands down if they disagreed with the statement. Data was collected from the blended high school chemistry course students who were students between the ages of 10th grade through 12th grade. The first statement was, raise your hand if you prefer this course setup to a traditional lecture-based course setup. The second statement was, raise your hand if you feel as though you are learning more information this way than in a traditional classroom. And the final statement was, raise your hand if you think you are understanding the material better in this way than in a traditional classroom. Their classroom was an inquiry-based learning classroom, whereas a traditional classroom is a lecture-based classroom. The results from the survey showed that the majority of students showed that they preferred the inquiry-based learning methods to traditional teaching methods. However, only about half felt as though they were learning more information than in a traditional classroom, while about 2/3 of students found that they felt they were understanding the material better overall. From the observations, I could conclude that there is a benefit to using inquiry-based activities with students, especially when they're based on their own virtual laboratory experiences. Students showed a preference for inquiry-based learning. Additionally, they believe that they learned more information and understood it better than in a traditional classroom. This overall information can be beneficial for current and future teachers, especially teachers that are looking for a way to benefit their students and engage them more in their class. Further studies and research can be done in both hybrid and blended classrooms and fully virtual classrooms, with virtual activities other than virtual laboratory experiments, teaching interdisciplinary or in multiple disciplines, and in classrooms of multiple ages, as most students in this study were in middle or high school. I would like to acknowledge the 4 professors that helped guide my research, and Mr. Benjamin Dar and the spring 2021 high school chemistry class at Rudyard's Junior Senior High School for allowing me to observe and take data from your class. Thank you for your time.
Okay, does anybody have questions for Courtney?
I can jump in with Courtney. Hi,
Go ahead,
Courtney. So I'm curious about your thoughts on whether this applies to, say, freshmen at a university level. So you found that virtual labs have a definite role in K-12 education and are sometimes better for student learning. What would you say, Jewel? What implication does it have for people who might want to teach at the freshman level in college?
So my original research idea that I unfortunately was unable to complete because of the pandemic shutting down the school that I was working in was to translate freshman level laboratory experiments to a high school setting. So high school students in an AP chemistry categories in high school still, or something at least similar. I think that allowing students similar to a college setting, it could also benefit them as they get into college, and then in college using virtual laboratory experiments can benefit students to.
Thank you.
Other questions for Courtney? All right, I feel a little bit like that question from Dr. Light was geared toward us chemistry staff. We're trying to improve. Dr. Light, do you have a question?
An interjection here. In general chemistry, we say that gases expand to fill the volume. I've done some experiments, some work like that in the classroom, where we asked them to draw the molecules before and after, trying to get at that understanding. And it's not uncommon to see the size of the atoms increase in the before and after diagram, because people think that expand to fill the volume means that the molecules themselves change their shape. instead of the spaces between them. So there's great activities that can be done to try to probe the misconceptions, and those visualizations are great for that.
I found that same phenomena happening with the 7th graders that I taught this semester, where they would think that the atoms got bigger when they were spreading out. So it is a common misconception.
And it persists sometimes. And it exists across all disciplines. I saw it, I've seen it in the physics classes. We try to ask them to explain how an eclipse happens to draw the relative positions of the planets. And people are baffled by it. It's a great opportunity to and then help them move forward. Thank you.
Thank you, Dr. Mine. Any other questions for Courtney? Okay, so we're about to get started here momentarily with Kiara Hamilton. We just want to, because the other room has an open slot at the end, we will be replaying Mariah Reed's presentation at 11:40 in the Beaker room, not to draw attention away from Emily. But if you wanted to hear that talk, you can go to that room if you would like to, so that Mariah's video can be heard, hopefully glitch free. So our next speaker is Kiara Hamilton, and she will be taking an opportunity year as well while she's working at a pharmacy, so that she can go to apply to pharmacy school. And her fun fact is that she loves to paint and has a dwarf bunny named Ricky. So here is Kiara's video.
My name is Kiara Hamilton, and I have chosen to do a literature review-based project on the health effects of volatile organic compounds through emission of air fresheners. Air fresheners are scent items that are used to add an aromatic or masking fragrance to the air. Air fresheners are an unidentified chemical mixture that can interact synergistically at various air temperatures and humidity levels. Volatile organic compounds, also known as VOCs, have a high vapor pressure at room temperature. This correlates with a low boiling point, which relates to the number of the sample molecules in the surrounding area, a trait known as volatility. VOCs are a form of air pollutant found in many common household items, such as air fresheners, cleaning products, and laundry detergents, which all are major sources of indoor VOCs. All types of air fresheners can cause negative health effects, such as migraines or asthma. And this includes the use of deodorizers, odor control, and neutralizer products. Limonene, alpha-pinene, and beta-pinene are key compounds found in air fresheners that can undergo reactions to produce byproducts that are harmful to health. Secondary contaminants such as acetone, acrolein, and acetic acid were created when ozone and limonene reacted. This caused an additional sensory irritant effect. The use of air fresheners should be avoided if possible. Chemical compounds in air fresheners that may react with ozone should be reduced, as they form secondary contaminants such as these VOCs, which cause a variety of health issues. Phthalate exposure from air freshener use has been linked to allergic symptoms and asthma as well. This appeared to be exacerbated down from a particulate matter and air pollution exposure. The Food and Drug Association and Consumer Product Safety Commission share authority over fragrances with the Environmental Protection Agency, handling certain regulatory aspects such as air and water pollution. Fragrances used could be hazardous and will not always be mentioned in the ingredients, as individuals buy these products to mask or cover up odor of other products, are unaware of the harmful chemicals being inhaled and the damages that could be caused. The Research Institute for Fragrance Materials inspects and collects data on the original fragrance ingredients rather than the finished product. So here we have the causes, the consequences, and ways of preventing cosmetics contaminations. They cause primary contamination, which is the risk of the product deterioration, and secondary contamination, which is risk to user health. Some primary contamination consequences involve O2 consumption, odor change, color change, and pH modification. Secondary contamination risks include injured skin, oral cavities, and eye irritants. The objectives of this study was to determine what volatile organic compounds are present in air fresheners and what the potential health effects caused by presence of VOCs in air fresheners are. The methods used to create this research involved the literature search of peer-reviewed articles using SpringerLink and ScienceDirect. Keyword searches were done with the terms air freshener, harmful fragrances, and everyday use perfumes. The search was later refined to articles published in the last 20 years and narrowed the search terms to VOCs present in air fresheners and FDA-approved air fresheners. VOC emissions from consumer and industrial goods were measured using a sampling device system for the determination of the VOC emission. The figure below describes a 5L Tedler sealed chamber. Large air samples were entered into the chamber to test the amount of VOCs emitted from the products tested. This excluded aerosol sprays as they were sprayed directly onto the Petri dish at the equilibrium point and entered into the inside of the chamber to be tested. So here we have listed the common commercial products that are bought that contain indoor pollutants and potential health effects. So the sources such as cleaning products, paints, air freshener, and printers cause pollutants of volatile organic compounds and volatile organic compounds and ozone reactants. This includes potential health effects such as respiratory tract irritation, asthma, headache, vomiting, respiratory system issues, and cardiac symptoms as well. VOCs found in a gas chromatography and mass spectrometry review should be presented when checking ingredients from the product label and MSDS. The chemicals found in the GCMS reported 9 of the 17 products regulated by the Consumer Product Safety Commission had little ingredients specified on the labels. 6 had only generic terms such as cleaning agents, softeners, or biodegradable surfactants. And 3 were under the categories fragrance, perfume, and essential oils. Hazardous and poisonous substances were omitted since no hazardous ingredients were specified on the product label, making people unaware. 207 industrial items were recovered from a local market, including air fresheners, shoe polish, leather, glue, cleaners, and insecticides. All products were divided into 30 types of objects, each with its own set of labels. A GCMS analysis was used to stop the depletion of benzene, toluene, ethylbenzene, and xylene from the manufactured product. Samples were analyzed for BTEX by headspace gas chromatography and mass spectrometry, with a limit of detection of 1 parts per million. BTEX chemicals were detected in 59 consumer products from 18 item types. As shown on the table on the right, the most commonly found items for these BTEX chemicals were found in whiteout, glue, oil-based ballpoint pens, and leather cleaning products. Acute exposure of these BTEX chemicals with any of these commonly used items can cause skin and sensory irritation, central nervous system health issues such as tiredness, dizziness, headaches, and loss of coordination, and respiratory system health effects such as eye and nose irritation. More than 84 compounds with 11 analytes were identified in over half of the 26 gel-type air fresheners being tested for this research. It was found that ethanol was contained in 76% of the products, benzoyl acetate was contained in 52% of the products, and acetone was contained in 48% of the products, and nothing was disclosed on the labels. Non-methane volatile organic compounds, also known as NMVOC, had antiperspirants were found to have the most propellants per can in a cosmetic category tested. Hairspray contained the highest total NMVOCs per can. Household aerosol sprays had a higher total NMVOCs level. Non-methane volatile organic compound emissions from domestic aerosol sprays are equal to the amount of NMVOC emissions from about 77.2 million cars. Now, as seen in this chart, in the cosmetic group, antiperspirants contain the highest amount of propellants, as hairspray contained the highest amount of overall NMVOC. Household air fresheners and insecticides carried a higher average of NMVOCs per can. And this was tested in household aerosol sprays using liquid petroleum gas as a fuel. Chloroform and carbon tetrachloride concentrations in indoor air were estimated based on kitchen, bathroom, and cleaning supplies. Concentrations of halogenated VOCs were lowest in plain bleach and highest in the surfactant added products. These are considered carcinogenic and contain inhalable risk factors. These two compounds were chosen because they are the most halogenated VOCs in household products. Laundry filter load increases oxidation processes on the filter surface as well, creating halogenated VOCs. Long-term use can cause skin irritation and harm to a certain extent, as surfactants penetrate the human body and destroy enzyme activity, causing the body's normal physiological process to be disrupted. Surfactants are toxic and can accumulate in the body, making the degradation process more difficult. So here we have the negative effects of chlorine presented in bleach. Chlorine bleach containing household products are frequently bought. These chlorine bleach containing products are then mixed with surfactants and fragrances already present in an indoor environment. These create halogenated volatile organic compounds present inside the household products. The use of these chlorine bleach containing cleaning products produces emissions of elevated indoor air levels of these halogenated VOCs. The inhalation exposure is then carcinogenic halogenated VOCs forming, which causes severe health effects. Each product had an average of 17 volatile organic compounds. 24 of the 133 volatile organic compounds are listed as poisonous or hazardous by the federal law in the United States. Each substance released at least one of these. Fewer than 10% of volatile ingredients in air fresheners are disclosed on the label. Volatile organic compounds are unreported in several fragrances. They have been detected in scented products, and many have ill effects to health on those young and old. Everyone is exposed to fragrance in many soaps, laundry products, and toiletries. The use of these scented products should be avoided, particularly if perfume allergies are present. These findings indicate that VOC exposure from certain consumer goods have exceeded acceptable levels and should be limited. Thank you for taking the time to listen to my research project. And I'd also like to thank Dr. Nguyen for her guidance through this thesis and making this presentation possible. Thank you.
Okay, does anybody have questions for Kiara? Lucas, go ahead.
So earlier in the presentation, you said that you detected minimal of the compounds that were actually listed. Like you detected more compounds than were actually listed. Is that an issue with what the law requires to be reported, or is that an issue with the reporting itself and the testing being done by the company?
Sorry, okay. No, everything's tested, and what I got from my research is that these companies are aware of the hazardous VOCs present. It's just they're not putting them on the labels to basically save like any suing, I'm guessing, and health effects. But now it's more of a discussion, and FDA is coming forward now with like all the like the chemicals that should be listed, and like they're just not. But those were the main ones I listed, were the ones that were the most hazardous and had the most effects. But there are a million others.
I have a quick question.
Go ahead, Justin.
Do you happen to know if these companies that produce these products, are they required to do third-party testing, or do they do this sort of testing like on their own products? Do you know the answer to that?
I don't know that actually. It's a good question, but it wasn't a part of my research. I didn't head that direction as far into companies, just more into the products.
Okay.
But I can get back to you about that. Absolutely.
All right. Thank you.
Any other questions? All right, so we're gonna move on to our next speaker, which is John Klustra. John has been working with me. So John's been working on, as you heard, cocaine analysis in currency, and he enjoys singing karaoke occasionally. Do you have a favorite song, John, that you like to do in your repertoire?
I usually like to do Simple Man by Shinedown. I like their version, so.
All right, so here is John's video.
everyone. My name is Jonathan Klustra, and I did a lab-based study for the analysis for the presence of cocaine and tetrahydrocannabinol on paper currency with my mentor as Dr. Nguyen. Start out, cannabis tends to lower motor skills. This has been found through many studies. It inhibits your reactionary skills when it comes to operating things such as vehicles, heavy machinery, or other types of machines in general, while cocaine has been shown to improve reactions and motor skills slightly up into a certain point. In 2006, it was estimated that 166 million people, or 3 to 9% of the world population, were constant marijuana users, while in 2015, there was an estimated 0.35% of the world population that regularly used cocaine. So why research drugs on cash? Well, high amounts of drugs on cash tend to have a strong correlation to drug trafficking in certain areas. This higher percentage of bills that are contaminated also correlate to higher instances of crime in these other geographical locations as well. Start out finding a method for swabbing. First, acetaminophen and aspirin were chosen as the base analytes to find the best method for swabbing. These findings would then be used as the basis for the analysis of THC and cocaine on paper currency. The swabbing technique is as follows. Step one was to put 0.1 grams of analyte on each paper separately. Then it was shaken off to mimic the handling of drugs before handling the cash. Then a swab was dipped in a solution of either methanol, ethanol, isopropyl alcohol, or deionized water, as well as a dry swab. This swab was then used to swab the piece of paper that had either analyte on it, and then this swab was dipped into 0.5 milliliters of methanol, which was then diluted by a factor of 10 with methanol. For HPLC analysis, 1 milliliter of those solutions was put into the HPLC vial for analysis, and the analysis was done with the following gradient for both acetaminophen and the aspirin, which is seen in the table there, with A being 0.1% formic acid and H2O, and B, which was 100% acetonitrile. This had a flow rate of 0.5 milliliters per minute. The findings for acetaminophen and aspirin testing. From testing, it was found that ethanol was the best solvent for swabbing. It is shown in both bar graphs down there between aspirin and acetaminophen. You can see that dry tended to leave or recover the least amount, while ethanol recovered the most amount, and methanol and isopropyl alcohol and water were all about average with each other. For the next step, acetaminophen and aspirin were both sprinkled onto cash in the same 0.1 gram amount. This was then swabbed using only ethanol on the left and the right side of the bill. As you can see down there, that both those bar graphs show the recovered amount of ethanol, just to prove that it did in fact work. Next up was the collection of paper's currency for sampling. First up, 10 ones, 5s, 10s, and $20 bills were collected in total from Marathon Gas Station, Austin Cigar Lounge, and the local Walmart in Sault Ste. Marie, Michigan. These cash samples were then sampled the same exact way as the acetaminophen and aspirin, where the swab was dipped in ethanol. The paper currency was then swabbed with the ethanol swab. The swab was then dipped into the 0.5 milliliters of methanol and then diluted by a factor of 10 with more methanol before testing. 2 bills were also contaminated with THC and cocaine separately. testing requirements for both HPLC and LCMS. On the left, you will see the HPLC gradient that was found, with A being percentage of water with 0.1% formic acid, and B being the percentage of 0.05% formic acid and methanol. This had a flow rate of 1 milliliter per minute, while in the right table, this was a gradient that was found from an adjuvant application for illicit drugs. It follows as A being percentage of 0.1% formic acid in water, and B being 0.1% formic acid in acetonitrile. This had a flow rate of 0.5 milliliters per minute. For the results, HPLC analysis for the cocaine and THC samples showed non-detectable levels of both analytes. So that was why LCMS-MS was included as another form of analysis, because it has a lower level of detection. This analysis via LCMS-MS showed non-detectable levels for THC. Below, you will see a standard curve graph and a bar graph for the cocaine that was found. It is important to note that the standard curve, 2 points were taken out of the standard curve to ensure that the line was more linear, so that the amounts of cocaine could actually be calculated due to them having higher peak areas that were found. And so on the right, you will see that those are all implied calculations of cocaine, and all the bills below that have a G with them refer to the samples collected from the gas station, as well as the cocaine bill, the spike sample. So it was found that ethanol was the best solvent to use for both acetaminophen and aspirin, but this ended up not showing any detectable levels of THC, including the spike sample for both HPLC and LCMS. Cocaine was in fact found though, using LCMS-MS, using a modified standard curve. But all bills were of low value that were contaminated between the 1s and the 5s from the gas station. So methodologies were found for all analytes for analysis, which this can be used for further studies. This includes both the HPLC and LCMS-MS. With no THC found and minimal amounts of cocaine found, it would be of value to continue this research. Due to that, we had to modify the standard curve in order to find the cocaine. So improvements on standard curve dilutions would also be very valuable. And it would also be of value to research the correlation between low value cash and illicit drug contamination. Thank you.
Any questions for John? Go ahead, Dr. Mosey.
Oh, so John, I got a question. On your graphs that you showed where you had cocaine contamination on the bills, I saw that you had your concentration on your left graph in micrograms per mils, and then your other one was in parts per million. How do you convert back and forth between those two units?
Yeah, I definitely meant to only have that as ppm there.
Yeah. I guess I was trying to figure out whether or not your values were on the standard curve or not. And being in different values was hard to tell.
Yeah, no, they were there. I just had the calculations a little messed up on that, / the labels for it.
The other question I have had to do with you chose acetaminophen and aspirin as your initial swabs to make sure that they were being found in your initial chemicals. And you chose ethanol for the solubility of those. Did you have as you chose ethanol, did you know the solubility of cocaine and of THC in ethanol?
I did not research that beforehand. Dr. Wynn suggested that I used acetaminophen and aspirin to start out, and so we went from there. But I never looked into that part of the solubility for cocaine and THC using ethanol.
I would assume they would be soluble, but it would have been, for your, I guess, peace of mind, it would have been good to know to make sure that they were going to solution.
Yeah, that would have been valuable.
Other questions for John? So John, do you think the bills that were positive at the gas station were all from the same person?
It's kind of hard to say. I mean, there's 3 1s and 3 5s, so I don't know. It could have been, might have been different people. Really not sure on that one.
It would have been interesting, I think, if we picked up cash at different, not just one time, but over a period of time to collect that, just to see. That would be curious.
Yeah, that would be interesting.
All right, other questions for John? I'll start introducing our next speaker, who is Lucas Shepard. Lucas started doing some peptoid synthesis a while back, and then as we all know, the pandemic happened. So he could not continue his research in the lab, but he has been doing some literature research on the same topic of peptoids. Lucas is looking to go to graduate school for chemistry, or maybe physical chemistry, and maybe even overseas. So he's still looking into that. And his fun fact is that the first paper he ever wrote, which was in 8th grade, was a physics paper.
Hi, my name is Lucas Shepard, and today I'm going to talk to you a little bit about the ideal peptoid structural and chemical properties which lend to their antimicrobial efficacy. So first, let's establish why it is necessary to discover new types of antibiotics. Well, antibiotic resistance is a rising global threat. The CDC and the WHO have classified numerous types of multiple drug-resistant and otherwise drug-resistant bacteria, and that list is only growing. There are many actions necessary to combat this threat, but one of these, and one key one, is the discovery of new drug classes. And one of these classes is peptoids. Peptoid drugs may be able to fill that niche better than peptide drugs, which are similar. So here on the right, we see a peptide, which has the R group coming off of this alpha carbon here, versus a peptoid, which has the R group coming off the nitrogen here. Now this lends to a property called resistance to proteolysis, which means it's harder for the peptoid drug to be denatured or destroyed by the molecules which already exist in bacteria as well as our own gut and become completely ineffective. So this review will discuss the effectiveness of peptoids, the mechanisms of actions of peptoids, and the ideal chemical properties which lend to their efficacy. So first, let's talk a little bit about the activity of peptoids. Peptoids are effective as broad-spectrum antibiotics. So as we see, peptoids have activity against Escherichia coli, which is gram-negative, Bacillus subtilis, which is gram-positive, and we have highlighted peptoid 1 because we'll see this in further structural tests, and S16-mer because it has the greatest level of activity. So with the MIC, that's the minimum inhibitory concentration. That's the minimum concentration at which the growth of this bacteria was inhibited by this agent. And we also have highlighted N-tridec-1,4-mer. This peptoid is notable because it has shown great efficacy against Mycobacterium tuberculosis, which is notoriously difficult to treat. One thing I'd also like to point out here is that all of these peptoids, with the exception of 1,6-mer, have shown some level of efficacy against Candida albicans, which is a eukaryotic cell. So in many conventional antibiotics, you have a level of selectivity where they don't hurt human cells because they attack specific targets, such as the S70 ribosome, which only exist in bacterial cells. And with peptoids, you do lose a little bit of that. Let's talk a little bit about the mechanisms of actions of peptoids. Peptoids really act through 3 main mechanisms of action. The first of these is membrane permeabilization. Peptoids act on the membrane, and as we can see here, we have a control Escherichia coli cell, which is untreated, and we have these various Escherichia coli cells, which have been treated with peptoids. And you can see that there is significant alteration to the structure of the cell membrane. This is akin to permeabilization. So this means not only could other agents, such as more peptoids or other drugs, get into that cell easier, but the cell contents could also leak out easier. The other mechanisms are intracellular. So we have ribosomal depletion, which means that now that bacterial cell can no longer replicate and make the proteins that it needs. And we also have chromosome denaturing. So now that cell can no longer reproduce because the chromosome has been torn apart. So let's talk a little bit about the structural properties, which are necessary for a peptoid's activity. And one of the most important ones, is charge. Peptoids must have a cationic net charge. So this means that they must have a net positive charge. And this is because the cell walls of most bacterial cells have usually a net negative type of charge. So in order to interact strongly, you have to have a positive charge. So here we see a structural assay in which these positively charged lysine groups are replaced with these negatively charged glutamine groups. And as we replace with more and more and the net charge goes down, we also see the activity go down significantly to this point where it is barely measurable. One of the other properties of peptoids is how these groups are arranged, because it's very easy to alter this property. So we can see here we have peptoid 1 again. And on the left is peptoid 1 normally, where you have a positively charged monomer, and then these NS-phenylethylamine monomers, which are neutrally charged. And you have 2 of those, and then another positive charge. And that's the sort of one group of a positively charged, neutral, neutral, positively charged, neutral, neutral. Whereas on the right, with peptoid 1 block, you have shifted all of the positively charged groups onto one side. And here, we actually see that that decreases the level of efficacy. So you see the minimum inhibitory concentration grow a little bit. But in the next peptoid, we see an opposite effect, where we've done the same thing. We've taken all of the positive groups and moved them to this one side here. And we actually see a slight increase in the activities against 2 types of Staph aureus, so one methicillin resistant 2, as well as drug resistant Escherichia coli. So this is extended spectrum beta lactamase producing, which is drug resistant. One of the other properties of peptoids, which can be changed and optimized, is their length. So here we see another peptoid structure activity assay with peptoid 1, where we take those positive neutral groups, and we have 2 of them here, which means a net length of 6 groups, 3 of them here for 9 groups, and then 12 groups and 15 groups. And as we can see, up to a point when we are increasing the length of the peptoid, the activity goes up. But we also see this selectivity ratio go down. And this selectivity ratio is the quotient or the fraction of the human cells which were lysed versus the minimum inhibitory concentration of E. coli. So we see that while the increasing length can somewhat increase the activity of these peptoids, increasing the length also increases their activity against human cells as well as bacterial cells. And this length is closely tied to hydrophobicity, which is also separately optimizable by group substitution. So here we see another peptoid, peptoid GN4, in which we've taken these 4 tryptamine groups and we replaced them with these diphenylethylamine groups, which are more hydrophobic. And as we do this, the selectivity ratio climbs a little bit because the activity against E. coli, Staph aureus, goes up significantly. But when we take this end leucine group and replace it with this group, which has a methyl addition, the activity increases significantly, but the selectivity ratio decreases significantly as well. So an increased hydrophobicity increases the toxicity to human cells as well as bacterial cells, and decreased hydrophobicity does the same manner. So that is a property which should be optimized. So what can we learn from all this? Well, when we look at a peptoid antimicrobial agent, in order to be ideal in their properties, a peptoid should have a cationic net charge. So it must have a cationic net charge in order to interact with that negatively charged cell membrane. A peptide should be moderate in length, usually about 9 to 12 residues found here. Once you get too lengthy, you start to increase the toxicity against human cells. And once you get too short, they start to not be very effective against bacterial cells. And separately, with group substitution, these peptoids should be balanced for hydrophobicity. And this should be done by group substitution and testing in the lab. Thank you for your time.
Any questions for Lucas?
I have a question.
Go ahead, Ashley.
So Lucas, I know you started your research in the lab, and you talked about hydrophobicity a little bit. Were you able to figure out what that threshold was for hydrophobicity?
No, I was not able to figure out an exact threshold for hydrophobicity. So that's why my main conclusion from that was that is a property which for each type of peptoid, each different peptoid group you have, you should try a few different group substitutions and additions in order to optimize that by lab testing.
Any other questions for Lucas? All right, so Jordan actually, who just got 2 trivia questions here, is our next speaker. She is an integrated science major, is that right, Jordan? Yep, so she's doing education, has been doing teaching full-time, and is going to be doing some long-term subbing until she finds a full-time teaching job. And she did the college Disney program. Can you elaborate on what that is? I've never heard of that.
Yeah, it's where you take about a semester off and you work for Walt Disney World. They put you in one of their parks and you just work crazy hours, but get free admission to the parks and get to make magic. Fun times.
Right, here is Jordan's video.
Hi, my name is Jordan Valad, and I am doing my presentation on how to successfully motivate students in a science classroom. So my interest in this topic stems from me being a secondary science education major. I'm hoping to have my own classroom come this fall. And my biggest question, and the biggest question that I know a lot of educators out there have, is how do I actually teach my students? Throughout my career here at Lake State and throughout my student teaching experience, I'm learning that all teachers are asking this question. And the biggest answer that I'm getting is we have to motivate our students. And why do we have to motivate our students? Well, those teachers who just teach content and are just lecturing from those slides in PowerPoint, they're losing their students' attention. And that loss of attention is actually leading to a lack of content comprehension. When our students aren't understanding the content, they're not going to be successful students. And in turn, we're not going to be successful teachers. So teachers have to be able to motivate their students to learn. Now, with this research I've been doing, I found some motivational techniques that teachers all across the world have been using in their classrooms. And this is from kindergarten all the way up to college age. So this part is not specific to a science classroom. But those motivational strategies are visual arts and aids, so ways to stimulate their students. And we will see later on, those were like prezzies, so like a PowerPoint, or others used videos or drawings in their classroom. Physical movement to get the blood flowing, creating more oxygen in the brain. This could be recess or just something for the students to focus, like hands-on work. Relatable content, that the content can be applied to their life, that these students could take this content and go out into the real world and be able to actually use it, which is really cool. Relationships, having these relationships built with students so that students know that you actually care about them and their academic success. So which motivational techniques are then best in a science classroom? Well, throughout this research, I used ProQuest. I put on a scholar filter so that way I was getting peer-reviewed articles. I was using some keywords so that way I could find these motivational techniques in a science classroom. Science, motivation, motivated, secondary education, students, all of these terms to get a good plethora of articles to then refine. And I refine them by searching for words such as brain breaks and physical motivation and visual motivation and online motivation, because, you know, in the new COVID-19 world we live in, online motivation is a huge part of it now. Those abstracts were then reviewed. I made sure that all the articles were at least 15 or not more than 15 years old. And I just made sure that the articles had these motivational techniques, that they were able to have data in there, and I could look at the methodology of how these researchers or educators could find out these motivational techniques that work best in their classroom. One of those motivational techniques was visual arts. This is a survey result from a Malaysian elementary science classroom. This teacher taught a lesson using drawings and colorings and paintings to teach science. And then they surveyed their students and asked them yes or no questions, whether or not they enjoyed science lessons, if they liked using 3D models for science topic. One of them said, "Did you like today's science lesson?" Just to gauge how the students perceived the lesson that day. Prezi was used in a North Carolina classroom. This is another survey of visual arts because Prezi is a PowerPoint kind of thing. And on this survey, students were given a 5-point scale, 0 being the worst and 5 being the best in rating each of these questions. So some of them were, how effective was Prezi in motivating you to learn more about science? And we have an average of 3. And then another one was, how effective was Prezi in helping you observe details? It was about a 2.9. The learning gardens. This was one of my absolute favorites that I found in all of my research, something that I would totally want to incorporate one day. These learning gardens were done by 3 Portland 6th grade teachers who wanted to test these students' motivation in urban areas. What they designed was a garden for students to interact with content. They could grow their own plants. They could learn about plants. They could learn about community service. All these aspects, really, really cool stuff. This is a flow chart that the school teachers actually made. And over here on our left, we see that we have culturally relevant information, was a motivational technique, and hands-on, so that physical movement right there. And it says that by using those, students were engaged, which then led to science class engagement, more of that, more science identity, more science learning, and actually improve science grades. So this is a great chart to show how motivation actually helps your students. Visual arts as a motivator, I saw in here, really awesome stuff. Surveys were used to make sure that these visual arts were being evaluated to see if they were actually working. We noticed that in figure 2, the survey about a Prezi, that 3.0 mean on if it was motivating to the students was probably not the best. But that just means that Prezi was maybe not the most effective tool. Not every student will learn the same way, and it's a trial and error. Prezi may not work, but maybe PowerPoint will. Maybe another visual technique will work, and it's just trying new things. In a science classroom, we can use these visual arts. Totally, we can. Videos can be used, diagrams, models, graphing, all of those stuff are great tools to use in the science classroom. So visual arts is definitely a good thing. Learning gardens. So that unit, like I said, incorporated multiple motivational techniques. The biggest were cultural relevance and hands-on activities, them getting in and actually gardening. And we know that that was visually stimulating for their students to get out there. They absolutely loved that. These students learned how to grow or learned how to garden. They interacted with the content and they got to work together to accomplish their like school goals, which is really cool to see. And I think teachers can definitely learn a lot from those learning garden lessons. What can I do now with this information? Well, I know that in a science classroom, students are most motivated by visual aids, physical activity, and culturally relevant material. And what I can do is that I can start creating lessons using these methods. I've been student teaching this semester, and I've actually already got to use some of these. I did an oil spill activity with my students last month, And I was able to use actually all three of those. I was able to explain to my students how this was culturally relevant material. I got them to think about oil spills and think about how they can help. A lot of my students were like, oh, I want to go help with the next oil spill, which was really cool. I got to do a hands-on activity. I got to have students pour oil over a habitat and then try to clean it off. They had this real world experience right in front of them where they got to use their hands, and they were probably visually stimulated, hopefully, just to get this task accomplished. So it's really cool to see motivational techniques used in the classroom. And I think that educators need to be constantly making sure that they are motivating their students to just create successful students and then in turn become successful teachers. Awesome. Well, thank you. I am Jordan Vlad.
Questions for Jordan? Go ahead, Dr. Light.
So Jordan, I have one. Of the different methods that you took a look at, which would you say is the most powerful in terms of motivation? If you had to pick the top one, what would you pick?
I think the top one was the culturally relevant material. When I was researching the learning garden, those students really enjoyed learning about what they can do and make their own garden. And I thought that was cool. And that's what I consider culturally relevant. With my oil spill activity that I did, I got to hear students say that, oh, I want to go and like help clean up at the next oil spill. And so this is something that's happening in their culture and they can do something about it. And so I think culturally relevant material, I think, is very strong. And yesterday at the poster session, I talked with Dr. Wright about what culturally relevant actually means. And it's not going to be an easy one to know culturally relevant. And I think as educators, we have to keep making sure and like assessing, is this actually culturally relevant material? Because sometimes it might not, even though to you, just because of those age gaps right there.
That's interesting. So thinking about your own student teaching experience, you're in a school that has a very strong Native American culture. And so I'm thinking about wondering if that oil spill activity, because fishing is such an important part of that culture, if any of that connected with students when you did it. You're on mute.
With the oil spill activity, it didn't necessarily talk too much about fishing. However, just a few days prior, we were talking about overfishing and commercial fishing versus like not like two-person boats, like what the natives used to do. And so we were incorporating that into the classroom, and the students were like, oh, like my dad, like we make fish nets, we catch like this. And so like that, you can kind of bring in cultural techniques into that aspect with the school, but the oil spill activity really didn't bring into the native aspects to that.
Okay, could be something you might add if you continue using it. Thanks, Jordan, appreciate it.
Other questions for Jordan? I had an interesting, okay, so as our chemistry students out there, how motivated would you be in lecture if we broke up chemistry lecture with a physical activity? Or would you just think that the professors were silly?
I think it would depend. Oh, sorry. I think it would depend on what the physical activity was and what it was pertaining to during the class.
Fair enough. So, IR stretching, or we have to do all that activities, right?
Nothing with titrations.
Nothing with titrations. That would be a tough physical activity, I think. But dance breaks probably during class, maybe silly. That's a good one, Lucas. I might use that. Run around pretending to be molecules in different phases. That would be a good one for Gen Chem, actually, when we're not having to social distance.
That's actually something that I do to teach phases of matter to 7th graders. It's like a huge part of how I teach is I make them pretend to be molecules in different phases.
That's good. That's good. Right. Any other questions for Jordan or comments? Right now is Emily is in the lead. Okay. And she is our last but certainly not least speaker. And she is one of our few students that I know of that has taken a job before finishing. What company are you at right now, Emily?
It's called Accurate Analytical Testing in Romulus, Michigan. Yeah, it's been fun. It's been stressful, but we're almost done.
I can imagine. This will be one less monkey off your back. So her fun fact is that she has 7 brothers. So it's not quite, Ashley had the 6 siblings. Emily's got 7 brothers. So that must have been real interesting growing up. But here is Emily's video.
Hi, my name is Emily, and today I will be presenting a spectrum of antimicrobial activity of 3,4-dihydroquinazolone compounds. So bacteria is constantly mutating and developing resistance to the antibiotics created to inhibit their growth. A series of new 3,4-dihydroquinazolone compounds were recently synthesized in the Mosey laboratory. They were primarily screened for bacterial growth inhibition properties against S. aureus. And the objective of this study is to evaluate the 10 compounds showing the greatest S. aureus inhibition from the previous studies for their ability to inhibit growth of additional gram-positive and gram-negative compounds. This will determine if these leading compounds exhibit broad spectrum activity or if they are particular to specific bacterial strains. It will also aid toward a better understanding of the mechanism of bacterial growth inhibition by these 3,4-dihydroquinazolone compounds. So in this study, there were 4 bacteria observed. One was gram-positive, that was E. faecalis, and then the other 3 were gram-negative, that was E. coli, A. baumannii, and P. aeruginosa. So one of the major bacterial targets for antibiotics is the cell wall. The size of the cell wall can cause bacteria to have a stronger resistance to the antibiotics than others may have. So a gram-positive bacteria has a thicker multi-layered peptidoglycan layer, while a gram-negative has a thin single-layered peptidoglycan layer. So there was 10 compounds observed in this study. These had shown good inhibition against S. aureus from the previous study. This research was conducted by first creating compound serial dilutions. There was 10 dilutions total. The first well had 100 microliters of the compound. 50 microliters of that compound was then transferred into the next well, which contained 50 microliters of DMSO. And then it was just carried out until the 9th well, which then left the 10th well to be solely DMSO. Next, I had to create the bacterial suspension. All of the bacteria was streaked on a TSB plate and incubated overnight at 37 degrees Celsius. And then 50 milliliters of sterile Mueller-Hinton broth, or MHB, was inoculated. The concentration of the bacteria was determined by measuring the absorbance at 625 nanometers, and the wavelength reading had to be between 0.08 and 0.12 in order to move forward. And then 0.5 milliliters of that solution was then transferred into 100 milliliters of sterile MHB to create the final concentration of the bacterial suspension. So this is what the assays looked like. So 5 microliters of each of the dilutions were added into the corresponding wells on this plate. 195 microliters of sterile MHB was added into the bottom 3 rows to create the control. 195 microliters of the bacterial suspension previously made was added into the top 3 rows. And then around the sides of the plate, 200 microliters of sterile DI water was added into those cells. And this plate was incubated again in the 37-degree incubator overnight. This table presents the results of the broad spectrum analysis. The software GraphPad Prism was utilized to analyze the absorbance reading from each of the plates. That absorbance reading was taken and a graph was made of the bacterial inhibition. And from the graph, the IC50 values were able to be determined. This value reports how much substance is needed to inhibit a substance's ability to reduce biological growth by 50%. So there were 4 compounds showing decreased activity, suggesting growth inhibition. And those compounds were SD1033, SD1123, TW1169, and then TW1139. Three of those compounds were inhibited by E. faecalis, the only gram-positive bacteria, while one of them was inhibited by P. aeruginosa, which is a gram-negative bacteria. So SD1123 was the only compound showing complete inhibition, and this is because the graph reached the baseline. So the other 3 compounds have the greater than BL at the end, which means that it was above the baseline, stating that complete growth inhibition was not observed. And then all of the other ones that show a greater than 125 represents that there was an increase in potency. It was not inhibited by the compound whatsoever. And then the S. aureus data in the first column was previously determined. So these 2 graphs show SD1033 and TW1169 against E. faecalis. As I stated before, they did not reach the baseline, so there was not complete inhibition from these compounds. And then these 2 graphs show SD1123 against E. faecalis and TW1139 against P. aeruginosa, the gram-negative bacteria. SD1123 did reach the baseline, showing complete inhibition of this bacteria. And then TW1139 did not reach the baseline, showing some but not complete inhibition of the bacteria. So overall, the compounds did not show broad spectrum antimicrobial activity. E. faecalis was shown to be more susceptible to growth inhibition by these compounds. And TW1139, since it was inhibited partially by a gram-negative bacteria, it possibly illustrates a different target for the gram-negative bacteria by these compounds. Cell wall biosynthesis is a plausible target for these 3,4-dihydroquinazolone compounds, but further studies need to be conducted to limit potential targets within gram-negative bacteria. I would like to thank Selena Malcolm for her work with the 3,4-dihydroquinazolone compounds. The results of her research with S. aureus is the foundation of this study. I would also like to thank Dr. Mosey for advising me and Dr. Hutchins for helping me in the laboratory. Thank you.
Hi, Emily. I've got a couple questions.
Okay, I thought you would.
Oh, don't be that scared.
Okay.
So one question I have, we kind of talked about yesterday, was that these are inhibiting the growth of Staph aureus and E. faecalis. Both are gram-positive organisms. And if we're going to move this forward in, forward direction, and we're going to have other students maybe screening other gram-positive organisms, what might be some that we could test that would be gram-positive?
Yeah, so gram-positive organisms that could be further looked into would be Streptococcus pyogenes. I don't know if I said that correctly. Another one could be Streptococcus pneumoniae. Also don't think I said that correctly. But I also did look into gram-negative ones as well. I know that there are some antibiotics out there for gram-negative bacteria. It's nalidixic acid, which is a chemotherapy drug. So you could always look and see how that one is working to inhibit the gram-negative drugs or gram-negative bacteria, because gram-negative bacteria is a lot harder to kill than gram-positive. So I feel like looking for antibiotics that are more specific to gram-negative is also important. And I think these compounds have the potential to do that based off of the one compound that had some inhibition for the gram-negative bacteria.
All right.
Hi, Dr. Hutchins.
Yes, nice job. I have a question. So you speculated that maybe cell wall synthesis was a target of these dihydroquinazolines. What led you to that conclusion?
So because of the layers, like the peptidoglycan layer, being different, the gram-positive bacteria will obviously let more in because the layer is a lot thicker, while the gram-negative is obviously a lot thinner. So cell wall biosynthesis is plausible because of what the layers are allowing into the cells, I believe. That answers your question. I don't know.
Okay, thank you.
Yeah.
Any other questions? All right, we're gonna adjourn, or in a couple minutes here. I think that it sounds like maybe the other room's still going with some questions. If you go back to the main room, we'll do our presentation of awards, and then it will be just a couple minutes for that. But you can just take a break, I guess, and then we'll do presentation of awards shortly.
Are you going to remove us from the breakout rooms to make it all one room?
Yes.
Okay, thank you.
Okay, hopefully everybody is back. Emily, I'll have to get your mailing address for your trivia prize there. You were the winner of the whatever room we were in, the Bunsen room. Yeah. Okay, so last spring we were not able to give out awards for our outstanding graduates, and clearly nobody's present for them, but we're still going to send out some things. So the prize that we will be giving this year for outstanding graduate is a cutting board with the periodic table engraved on it that says I like to cook periodically. So if you are an outstanding graduate, you may stop by my office next week to pick up your prize. And we have them in the different categories. So for last year's 2020 graduates, the outstanding graduate in the area of chemistry, you also get a certificate, is Sydney Smith. For biochemistry was Sierra Strutz. And for forensic chemistry was Daphne Patton. All right, so those will be mailed to those students with their addresses hopefully still on file. And the drum roll for this year's students, the outstanding graduate in the area of chemistry is Justin Blaylock. For biochemistry, Brendan Lukomsky. For forensic chemistry, Jocelyn Birch. And our first graduate of cannabis chemistry goes to Marielle Ball, who is not here, but that will be given to her as well. So you may congratulate all of the graduates and also our outstanding graduates. We have one more award to give for our special faculty member who is retiring this year. And he will be also getting the same thing that says the 2021 Outstanding Professor of Chemistry, and that goes to Dr. Dave Mighton. So Dave, you can stop by my office after to pick up your award that I had to hide when you popped into my office to look at them.
Thank you very much.
Okay, so if anybody has questions, they can stick around afterwards. We're happy to entertain them. Otherwise, thank you, seniors, for all of your hard work. You did a great job today, and you will be getting a survey from me next week. And you can also fill out your class climate survey. That would be super helpful. Enjoy the rest of your weekend, and thank you all of the attendees for coming to the senior presentations. Have a good one.
Thank you, Dr. Lynn.
Thank you.